Today's problem, swap kth nodes from ends. Okay, so given a singly linked list of size n and an integer k, so we are given with the size n and an integer k. You need to swap the kth node from the beginning, the kth node from the end of the linked list. Swap the nodes through the links, do not change the content of the node. Okay, so the question basically says like we are given the size of the linked list. We are given a linked list. Along with that, we are given two other values. One is the size of the linked list. Other one is an integer k. So we need to swap the kth node from the beginning and the kth node from the end. So if we are given say k is equal to 2 and we are having a linked list of length 5, then we need to swap node 2 and from the back it will be node 4 and we need to swap those two. And the main thing is we should not change the content, we need to change the links. So the first example, n is equal to 4, k is equal to 1, and this is our linked list 1 2 3 4. So k is equal to 1, this is 1, the kth node from the beginning, and this is the kth node from the back, and after swapping 4 will come here and 1 will go here. So 4 2 3 1 will be the one. Then the next one, if k is greater than n, so in this case our k is greater than n, so we cannot swap because there is no kth node at the very back or okay or at the front. So swapping will be invalid, so we just return the head node. So let's actually check. So let's say we are having any linked list 1 2 3 4 5 6. Yeah, let's have a linked list like this, and here our n is 6, where n is the length of the linked list, and our k, say our k is given as 2. So k is less than 6, so swapping is valid, so we need to actually swap the value. So what is the kth node from the beginning? We can clearly see 2 is the kth node from the beginning. What is the kth node from the back? We can see this is the kth node from the back. So one of the direct way what we will do means we just make a loop. We just loop through the nodes, and we know that this will be kth from the front, and this will be n minus k plus 1 from the front. So we just start traversing the linked list from the front, and if we are at the k, if this kth, if we reach this node, we just change its value to 5 and we keep on moving, and when we reach the n minus k plus 1 node, that is the kth node from the back, we just change its value to 2. But it clearly, this is a direct approach, but it directly says in the question like we need to swap through the links, we should not change the content. We need to somehow just change this link, we need to move this to here, and this will be moved to somewhere here, and we need to do that kind of an approach where we need to change the links and then do the swapping. So that's what we need to do. So we know our two values, this one and this one. What is the previous value for this one? So for 2, the previous value is this one, okay, and for 5, the previous value is this one. So the next of this previous is our one node to be swapped, and next of the other previous will be the next node to be swapped. So one observation that we need to see is that the next of this previous must be changed like this. If this previous is not equal to null, okay, if the previous is not equal to null, then its next has to be changed. If it is from the front, let's say this is x, let's say this is y, if the previous x is not equal to null, then it's next. Suppose this is the next. Okay, we have to remove this link. This link must be removed, and we have to have a new link that is pointing to the 5, that is, it's the kth node from the end. Same way, this is our previous y and this next. So currently it is pointing to this 5, but we are swapping, so we will be changing it, and this must be the next. If previous of y is not equal to next, this has to be changed here. So our updated answer must be 1 5 3 4 2 6. So it has to be something like this. So what we have done now, we have moved 1 to 5 and we have moved 4 to 2. Like this part is done, but still this 3 and 6 needs to be done. It can be just done with the normal the swapping. So for that we use a temp variable, and this is equal to x node. So let this be x, this be y. So this temp is equal to the next of x. The next of x is, let's say it's 3. Okay, now this x dot next, let it be equal to y dot next. Y dot next is 6. So our x dot next will be updated as 6. Now y dot next will be updated as 3. In this case, with respect to this case, it will be like this, but the approach is same. So y dot next will be 3. So our x dot next, so this pointer, instead of pointing to here, okay, it will go all the way along to this one. Okay, now the 6, now the next of y, that is, instead of 5 pointing to 6, it will be pointing to 3. So that's the approach that we'll be doing. Here we are not changing the values of the nodes, we are just changing the pointers here and there. So it's simple. Like we will be finding which is the, let's say x is the node from the beginning, y is the node from the end, which needs to be swapped. So along with finding this x and along with finding this y, we will also calculate the previous of x and previous of y. And if this previous of x is not equal to null, then its next will be y. And if previous of y is not equal to null, and its next will be x. Then after that we will be doing some the normal swapping that we usually do, that is, have a temp variable, let it be equal to x dot next, because all the remaining nodes has to be interchanged accordingly. So let's have a temp is equal to x dot next is equal to y dot next, and y dot next is equal to temp. So that's it. That's the idea for this problem. And the time complexity, like we are just traversing through this once only. So we are just traversing through the linked list if size n. So our time complexity will be big O of length of the linked list. Space complexity, we are not making use of any extra space, so it will be big O of 1. So let's start. If our head is equal to equal, for any linked list type questions, it's always good to start with this. If head is equal to null, just return head. Okay, so if num is greater than k, so if k is greater than num, here num is the length of the linked list, just return head, because that what given here. If k is greater than, return the head. Okay, now our beginning node will be at k, our end node will be at n minus k plus 1. Okay, so let's have some pointers. So node x, as I told earlier, let's have some pointers. Node x is equal to head initially, node previous of x is equal to null. Okay, initially we are starting from this head and its previous is null. Of course, this is the basic logic. Now node y is equal to head, and node previous of y is also equal to null. Okay, now we are just going to locate the x, the y properly. Okay, so for int I is equal to 1, I is less than or equal to k, I plus plus, I is less than k, sorry, my mistake, I is less than k, I plus plus, we just move x is equal to x dot next. Before that we have to move the previous x is equal to x and x is equal to x dot next. Same way for int I is equal to 1, I less than n minus k plus 1, I plus plus, move the previous to the current y and move the y. So after completing this loop, we will be the x will be at the position of the node which needs to be swapped from the beginning, and its previous will be previous x, and after completing this loop, like the y will be at the node which needs to be swapped, and previous of y will be its previous. Okay, now like we are just changing the link of previous x and previous y. So if previous x is not equal to null, if it is not equal to null, so we are just changing dot next is equal to y. Same way, if previous of y is not equal to null, we are just changing its link, previous y dot next is equal to x. Okay, now the normal, like the other nodes has to be just swapped accordingly. So let's have a node temp is equal to x dot next, then x dot next is equal to y dot next, and y dot next is equal to temp. Here one thing to note that we are not changing any of its values, we are just playing around with this next. The next means the links. Now if k is equal to 1, just say head is equal to y. If k is equal to num, just say head is equal to x. Now just finally return head. So this is some extra condition that we need to take care of. Okay, so we are having some we cannot find, so this k, okay, variable k, symbol variable n, yeah, okay, is there any other way? No. Okay, it's because I didn't change, this k was uppercase, I didn't change. So the first one is okay, we are getting it. Let's submit. Okay, so just this is the concept, just find the node from the beginning along with its previous node, just find the node from the back which will be at the n minus k plus 1th position and its previous node. Now just change the links of the previous node. Previous dot x will be moved to y, will be now pointing to y, and previous dot y will be now pointing to x. So that two nodes get swapped. Now the other remaining links must be also planned accordingly. For that, the usual swapping concepts, making use of a time variable and just moving around with the links or the pointers will do the job. So just do node temp is equal to x dot next is equal to y dot next is equal to temp, and these are some extra conditions that just need to check. If k is equal to 1, just set head is equal to y. If k is equal to num, just set head is equal to x. So like if k is at this very position, at this position, we just make it as y. That's only like, so that's it, and yeah, that's the whole problem. So the time complexity here, big of k, or we can say in worst case it will be big of n plus big of n, big of length of the list, and no extra space is used, so big of 1. So that's the today's problem, swap kth nodes from it.